Greetings and welcome to Hobo University, where your professor will teach you what you need to know to get started with solar, batteries, and understanding electricity. For the entire month of September, which I'm calling Subtember, because this is all about you, my subscribers, I'm going to take a break from doing product reviews and instead post educational content that will not only answer most of the questions that I receive on a daily basis, but more importantly, educate you, the end user, on the typical kinds of products that I review on this channel. Now, we all know the proverb, give a man a fish, feed him for a day, teach a man the fish, and you feed him for a lifetime. Well, hopefully, I'm going to teach you guys how to fish for electricity without getting shocked. So, let's find out. HOBOTECH. Today's lesson begins with understanding electricity, at least at a basic enough level on how it relates to solar installations, batteries, and power stations. So by the time you finish this multi-part series, you should have answers to your questions regarding concepts like volts and amps and watts and watt hours and amp hours. So what are volts and why is voltage in batteries, solar panels, and related equipment so dang important? So I need to keep this at a very simple descriptive level. It's not going to be 100% scientifically correct, but it's going to explain the concept. So in an electrical circuit, voltage can be best explained as the pressure or difference in potential between a positive and a negative charge. So pretend like this is your battery. You have a positive and you have a negative. Electricity tends to flow from the negative to the positive. This flow or difference in charge is what we're calling voltage. And the faster it flows, the higher the voltage is going to be. So this battery has a positive and negative lead. The one with positive is going to be labeled with a plus sign and is usually labeled red, and the negative is going to be labeled with a minus sign and it's typically black. Now this negative lead is usually incorrectly called a ground, although in a vehicle, if you have this battery in a vehicle, so let's go ahead and draw our car. I'm just making a crappy one here so you know what I'm talking about. I never said I was an artist. So typically in a car or an RV or any kind of vehicle, this negative is actually attached to the chassis in the car. And a lot of people will call that grounding. That's not really a ground. A ground is something that actually goes, you say this is the earth down here. A ground would be a ground rod. In this case, it would be connected to that, and that would be considered grounding to the earth. But that is not what we're talking about today. That's a completely different subject, so we're going to go ahead and ignore that. And just for clarity, there is a big difference between DC or direct current like you would have in a battery, or AC power or alternating current like you would get from utility power or an inverter. We're going to save the whole AC power thing for another day, as this lesson is focused on DC as it relates to batteries, solar panels, solar controllers, and things like that. Now, a great way to understand the concept of voltage as the difference in pressure in a circuit is to use gravity-fed water pressure in a pipe as an example, because pretty much everybody understands water pressure. The deeper you would dive down into water, the higher the pressure, the more your ears want to pop, and the more uncomfortable it gets because the water pressure is pressing on your lungs and your head and everything else, making you very uncomfortable, eventually crush you till you die. But in this case, we're going to do what's called the Pascal's barrel experiment. And this is going to show you how when you actually pour water into a long pipe that goes into a sealed barrel, the pressure can build up so high it makes this barrel explode. There's actually a really good video on YouTube where a school teacher sets this up and blows up a barrel in front of her students. And when I saw that, I said, this is going to be a great way to teach people voltage because everybody understands water pressure. Pressure in a hose, a lot of people use that example. I'm going to use pressure in a pipe going to a barrel. Because the water in this case is actually not moving. Water in a hose, people always think it has to move to create force. In this case, it's creating force just by the weight of the water. And in Pascal's barrel experiment, you actually have water being poured into a pipe through the top. This barrel is already filled with water. So we'll go ahead and fill it with water. All the air has been taken out. And then he pours water in. Now I have a pitcher of water here, but obviously it'd be a hose or buckets or barrels or whatever. And they pour that into this pipe. And at a certain point, the water pressure is so high, depending on how high this is. Now, the higher you go, the more water pressure you get. So this is the same thing as voltage. So imagine down here is your positive, and up here is your negative, because as we know already, electricity flows from negative to positive. So imagine this is like a battery. You have a negative terminal and a positive terminal, and this column of water is creating pressure. That pressure is what we call voltage. So you're looking at this saying, okay, water is just sitting in this tube. It is creating pressure, which is the concept of voltage, because there's a difference in positive and negative. And this is a concept we're going to get into later. The thickness of this pipe, no matter how wide it is going to be amps. But in this case, the water is not moving. It's just sitting still in the column. So since the water is sitting still and not actually moving, but it's still creating pressure, this is voltage without amps. Now we're going to cover amps separately in the next segment. So in regards to solar panels, voltage is the most important spec because you have to design your entire system around it. This includes purchasing solar panels for a power station or a solar generator or a charge controller, as knowing the maximum input voltage is vital. Because virtually everything on the load side of a circuit, in this case, let's make a light bulb, this would be considered a load because in the case of the battery, you have your positive hitting one side and your negative coming up and doing the other side. Inside the light bulb, on one side of the filament is a positive, on the other side of the filament is a negative. So anything that's being powered is considered a load, and most loads are only designed to work within a specific voltage range, and that's with few exceptions. In this case, this might be a 12-volt light bulb. So in electrical terminology, voltage is expressed with the letter V. So when you see the letter V in an abbreviation, you can assume it has something to do with voltage. Okay, so for example, on a solar panel, let's pretend this is a solar panel. It's got a positive and negative output on it. You're going to have two voltage-related specifications. One is going to be the VOC, or voltage open current, and the other one is going to be the VMP, or voltage at maximum power. So these are both voltages that are in a solar panel. So the open circuit one is going to be the higher one, and the voltage at maximum power is going to be the lower one of the two. So the higher one is the one you want to use to design your solar system. The lower one is actually what the voltage of the panel should be under maximum power. That's the maximum sun with maximum amps. Voltage open circuit is when there's nothing hooked to either one of these. That would be the voltage that you would measure between the positive and negative. Now this voltage is not to be confused with the actual rated voltage of the solar panel, because the rated voltage of the solar panel is most likely going to be something like 12 volts or 18 volts. Now this actually means the same thing, because a 12-volt solar panel that's 100 watts or so, 150, 200 watts, is going to output 18 volts when it's at its VMP. So VOC might be something like 22 volts. So the VOC would be this one, VMP would be this one. And this is the marketing term, because they just say 12 volts because most people charge a battery with a solar panel, so they say, oh, it's good for charging a 12-volt battery. But it's actually an 18-volt solar panel. That's what most of us would call it in the industry. So larger solar panels might be 24, 36, or 48 volts. When a brand is selling you a 12 or 18-volt panel, it's the same thing, so don't get confused. Now, the reason why solar panels have to output 18 volts instead of 12 is because you need 14.4 volts to charge a battery with a solar panel. So you need a solar charge controller that would go from the 18-volt panel, convert it to 14.4, which would then charge your battery. So the same goes with the larger solar panels. So when they tell you a panel is 24 volts, it's going to put out somewhere between 30 and 36 volts. So this one is actually going to put out that kind of voltage. And these 36 and 48 panels are considered residential panels. These are the things that are going to be on the roof of your house. You might have a 400, 500, or 600 watt solar panel on your RV or your van. These are considered residential. And these suckers can actually output 60 plus. These are designed for large systems because a lot of solar generators top out at 60 volts. Some of them go to 150 or more, and that depends on the solar generator. So in my case, on my property, I have 50 volt panels, and I have them in groups of 10. So 50 volts times 10 in series, 500 volts. Now this is VOC. They actually output around 420. So this would be considered 500 volts. Sounds like a lot of volts, and it is, but for a residential system, That's not unheard of. Now I'm going to explain in the future the reason for running such high voltages when we talk about amps in the next segment. Now speaking of solar charge controllers, which we're abbreviating SCC here, they are on the load side of a solar panel, meaning the power comes out of the solar, goes into the solar charge controller, so that's considered a load. That means you have to respect the voltage range they operate in. For example, many solar charge controllers, like mid-range cheaper ones, they top out at 150 volts. In that case, you want to make sure that the solar panels that you're running in series, when added up, their VOCs does not exceed the voltage on your solar charge controller. And this is VOC voltage. So in this case, we have a solar panel that is outputting 40 volts. We've got 3 of them. That's 40 volts VOC. Multiply that by 3, you get 120 volts for your solar array. Then you'd have your positive go into your positive and your negative go into your negative. And that solar panel would actually run the solar charge controller at 120 volts. So in this case, it would be 120 volts. Solar charge controller can handle, in this case, 150 volts. So when you're buying solar charge controllers, make sure you check to see what the maximum voltage is so you know what kind of solar panels to buy. Don't ever buy your solar panels before your charge controller. I see so many people, they go out and they see a great deal on solar panels. They buy 30 of them, and then they realize that their solar charge controller they're going to need is going to be like $1,200. And then they're like, I just saved a bunch of money here and I'm going to spend it here. So make sure you shop your solar charge controllers first before you buy your solar panels. And in the case of solar generators, which we call in this channel SoGens, they have their own built-in solar charge controller. So your solar panel would go instead to there and to there. So you can't hook up both at the same time. It's one or the other. Your solar generator or power station has to be fed directly with a solar panel because it has one of these built into it. So in the case of your solar charge controller, say it can handle up to 20 amps. So you'd have to figure out amps separately, and we're going to do that in a separate video, to make sure that you're not exceeding your solar charge controller's input on its amps. Now, do be aware that most solar charge controllers do have a specific voltage range that they work the best in. In this case, we know the max is 150 volts, so that's the max. But the ideal range, it might be like 70 to 110 volts. So this is the range you want to shoot for in the case of your solar controller. Now, you'll have to look at the specifications to see what the ideal range is for your MPPT controller, but it's probably something like that at the max is 150. That means if you keep the voltage in this range, it's going to put out the most power. And that also means when you buy your solar panels, you want to keep this range in mind. You want to be able to add up those solar panels so it is in this range. In this case, I was doing 40 times 3 or 120. It'd be slightly out of range for 110, but it's not going to be that much of a difference. As long as it's close to this number, you should be fine. Now, what about voltage as it relates to electronics? Because we're just talking about solar here, but what about things like maybe a radio? You have a radio that you're going to power from a battery or an external source. Now, let's say this radio is a 12-volt radio. So say you have a 24-volt power supply and you want to send it into this radio. Well, 24 volts is twice what this radio can handle. What do you think is going to happen to the radio? That's exactly right. You're probably going to destroy it, or what we call letting out the magic smoke. And you don't want to let out the magic smoke because that means that your product is no longer any good. This also goes for your portable power stations. So say you have a Jack Eddy power station, right? It has its positive and negative like we've talked about before. And say its range is going to be 60 volts. 12 to 60 volts, which is very common for a small or mid-size power station, 12 to 60 volts on the solar input, okay? So what if you put in a 40-volt panel? It's within that range. You're going to be all right. What if you put two 40-volt solar panels into it? What do you think is going to happen if you put 80 volts into a 60-volt maximum panel? You're going to let out the magic smoke. You don't want to do this to your Jetty because it's a pain in the butt to return. So it is very, very important that you actually watch my product reviews, because I will tell you in every single one of my power station reviews what is the range that this power station can do. Is it 12 to 60 volts? Is it 12 to 150 volts? These are very common here. So 12 to 60, 12 to 150. Sometimes it's only 12 to 30. And this would be like on the very small 300 watt, 500 watt power stations. A lot of them are only 20 to 30 volts. So depending on what the range is going to decide on what solar panel you're going to plug into it. Because if you exceed those numbers, good power stations will just stop you and give you an error message. The cheaper power stations are just going to let out the magic smoke. And if you want to find these numbers, you might not even find them on the brand's website. You probably have to download or read their user manual to get these ranges, because a lot of times they don't even publish this on their websites. Okay, so say you're a DIY person, you're going to build your own power system from scratch. It's very important to know what voltage your battery bank's going to be, because you're sending solar power from a higher potential voltage to lower. The solar panel total voltage needs to be higher than the battery bank voltage. So in an example I will give you very quickly, if you have a 48 volt battery, which this is common in a home power system, and you have a single solar panel with a 40 volt output, and you try to send that power to this battery, nothing's going to happen, because you would have a solar controller in the middle. So in between this, you never put a solar panel directly on a battery, never. Has to have some kind of solar charge controller in between. The solar charge controller is going to see the 40 volts, laugh at you, because it doesn't have enough to do the 48 volt charging. 48 volt batteries typically require 56.4 volts or more to charge completely. So unless you have two of these solar panels, so now you have 80 volts going to your solar charge controller, it can charge a 48 volt battery no problem, because you're pumping 80 volts in and getting this 56.4 out. So charge controllers can take the power down, but it's not going to take the power up for you. Now, as an example, if you want to get really fancy, say you're making 20 solar panels and you're going to put 20 solar panels in your solar charge controller. So the higher that potential difference, the more efficient it's going to be, because MPPTs do love higher voltage. So you want to put your solar panels in series to get the highest voltage that your charge controller supports in order to most efficiently charge this battery. Now for home solar builds, a 48 volt battery in this case is the best way to go, because a higher voltage means lower amps mean smaller cables, and smaller cables mean cheaper cables. It also means you're going to lose less to heat, because when you transfer power from one thing to another through a cable or a wire, that wire heats up slightly. You might not be able to detect it, but it does slightly heat up, and that energy just goes into the environment. So you don't actually get that power back. So the less you lose the heat, the more you get to keep for yourself. The downside to 48 volt batteries is they require a 48 volt inverter. And a 48 volt inverter is what you would need to get electricity out of. So you're going to plug your appliances into this inverter. It has to be a 48 volt inverter. You can't do a 24 or 12 volt battery on a 48 volt inverter. These are also more expensive than 12 volt inverters. 12 volt inverters, what you'd find in a vehicle or an RV. 48's usually what you find in a home or off-grid system. 48 volts is really what is considered the upper limit for safety, because you can touch the terminals on a 48 volt battery and barely feel anything, where if it was a higher voltage, you could get shocked and potentially die from the electrical shock. Now let's move on to the next one, which is a 24 volt system. This one is a little more common in things that would be like a truck. So trucks and large RVs might have a 24 volt system. So in a heavy duty vehicle, some of you may own some diesels that actually have two batteries that run in series to do 24 volts for a starter. It uses less amps to start the vehicle, heats up the cables less. So a lot of the larger vehicles have 24 volts. And the good thing about 24 volts is that there actually are a lot of appliances out there that will actually use 24 volts, like a refrigerator. We all have seen some of my reviews, hopefully, on 12 volt refrigerators. Most of them can do 12 volts to 24 volts. In fact, I don't know of any 12 volt refrigerator that doesn't support 24 volts. So you can use that in this ecosystem here and it will be fine. Not all 12 volt appliances will work on 24 volts. You have to double check it. Or you know what'll happen, you let out the magic smoke, and nobody wants to let out the magic smoke. And finally, we're going to go to everyone's favorite 12 volt system. And 12-volt systems are pretty much what you get in a car. And yes, this is a horrible picture of a car. I don't care. You get the point. But most vehicles nowadays have a battery inside. That's 12 volts. Now, there is an exception to this, and that's a current exception, and this is my version of a Cybertruck. Not a very good Cybertruck. I can put a window in there, and I guess we'll put a wing on it for fun. I believe the Cybertruck was the first one, or maybe Tesla has other vehicles that run on a 48-volt architecture, but almost all vehicles on the road use 12 volts or 24 volts. Just now, there are automakers starting to work with 48 volts, and the reason is wires are cheaper, they're lighter, so you're saving weight and cost by going to a 48-volt system. The problem with a 48-volt system in a car, try to find a 48-volt stereo. You're not going to find one. You're not going to find a lot of things 48 volts that's in a car. Electric bikes are generally 48 to 52. Now, some of them are 36. The really, really cheap garbage ones are 36. You don't ever want to buy a 36-volt one. 48 to 52 volts for an electric bike, and that means they have accessories like headlights that are 48 volts, and that is transferring to the auto industry. So they can actually, now they're getting higher and higher powered LED lights for things like headlights in 48 volt vehicles and Teslas. Now, Tesla does design a lot of their own stuff, but this is going to catch on. Eventually, all cars and trucks are going to be 48 volts. And that'll be great because it's way more efficient, less cabling, less hassle. The downside to 12 volts and running a 12-volt inverter is going to be the fact that that inverter is going to be limited to around 3,000 watts. Now, I've seen some 4,000 watt inverters, but those cables are humongous, okay? If you're going to actually build a 12-volt system and have a 3,000 or 4,000 watt inverter, your cables are going to be like that thick, and they're really hard to bend and hide. So generally 3,000 watts is about high as you want to go on a 12-volt system. Now back here on our 24-volt system, you can pretty much double that, right? And you can have an inverter that would be around 6,000 watts. And that's, at that point, the cables again get too big. So 24 volts, 6,000 watts, 12 volts, 3,000 watts. And then the 48-volt systems is pretty much sky's the limit. A lot of those will be 18,000 watts. I think that's about as high as I've seen, although you can probably take it to 24 kilowatts. Pretty much where we are today on 48-volt inverters, 18 kilowatts is usually the limit. Then again, you start getting to the fat cables again. Okay, I hope you soaked that all in. I know this video was a lot longer than I expected it to be for just volts, which is why I'm splitting it up into multiple sessions. So now that you're an expert on volts, part 2 is going to be about amps. Amps are super important. You have to design your system around amps as well as volts. So I'm going to cover hooking up solar panels in series and parallel in a separate video. I touched on it here, but that's a whole other topic. So be sure that you subscribe if you're not a subscriber already, because you're going to be notified when these new videos drop. And like I said, I'm going to do this all through the month of September. Bunch of educational stuff on my new whiteboard. Hopefully you guys enjoyed this hilarious form of art that I've started to draw. Yeah, that's my electric bike drawing. So hopefully you guys enjoyed this. If you did, make sure you leave me a comment below, give me a thumbs up, and spread the word. If you think that my videos are educational and can help others, please share. This is an experiment I'm doing. I'm doing this on my own dime. I'm not going to make any kind of money from doing this kind of content. There's no paid sponsors. I bought all this myself. If you could, please share the video, like and subscribe. And as always, thanks for watching, and we'll see you next time.
Odin commands you to like and subscribe, and clean my litter box.